or just generally concerned about points and grades and stuff like that, I understand that all of us teachers, we have like slightly different systems, and it's hard because you got to keep track of all the different systems, and it's sort of a pain in the butt. So with me, I thought that I could just clarify a little bit, just sort of philosophically, what you can do to earn the most possible points in this class. And I'm going to actually like write this up and post it, because I think it's easier than actually remembering all the rules. And it allows for a lot of flexibility, which I'm good with. So here's the short and sweet version of how to get the most points in this class possible. Number one, do your absolute best to learn as much physics as you possibly can every single day. The more you learn physics, the more points you're gonna get, period. The second thing is, give me evidence of what you are learning and what you're doing. So what you show me allows me to determine whether or not you're learning physics. And the third thing is, make it as easy as possible for me to evaluate your effort and your learning. And this is where like all of the little specific things like, oh, I want you to turn this in this way, and I'm gonna do late work policy this way. All of that, what it really boils down to is, there's so many of you, and there's only one of me, and I could tell for each one of you individually how much you've learned and how much you've understood if I could sit down and have a 15-minute conversation with you, but I can't. So what really helps your, like if what you want to do is earn some points, what really is going to help that cause is if you just make it unmistakable to me. I am working my butt off, and I'm trying to make it as easy as possible for you to evaluate my learning and understanding. So that's why things like turning it in with a picture on canvas and on paper. Like, think about how much easier that makes it for me, because then I can see when it was turned in without having to I don't have to do anything. Canvas does it. And I can see the work. Put your names on stuff. Turn things in on time. Like, all of that stuff makes my evaluation of your learning and your effort a lot easier. And that's why, so for example, I'm asking you to close your Chromebooks during, like when we're not actually actively using them. And the reason is because if I look at you and I see the back of a Chromebook, how do I know what you're doing? How do I know what you're learning? You've made it more difficult for me to evaluate. If you are working on stuff for other classes, it doesn't make it easier for me to say, wow, this person is really killing it when it comes to physics. So that's the stuff that I'm looking to have you think about. Just like the easier you make it for me to evaluate your effort and your learning, the easier it's going to be for me to say, oh, they get full points on this assignment. I saw what they did. I saw that they were learning. It's right here. All the evidence is here. It was all turned in on time. Easy, easy, easy. Full points. So for those of you that have anxiety about points, it's really those three things. And I'll try to keep reinforcing that, because what I would really like to move to is kind of a lab environment, where not a lab like we're doing a lab together, but a lab like we are a research lab, and our research is into cool physics stuff. We're just going to play around, we're going to explore, we're going to think about things that we don't understand, because it's fun to do that, and as we figure stuff out, we're going to collaborate with each other, because that's the best way to learn. So that's going to be kind of my guiding philosophy. Let's see. And then one other thing I wanted to mention, so we're gonna start our first lab report today. And I mentioned the way that the formative work is broken down is that we're gonna have these 4-point assignments that are like mostly just, are you using your class time, are you being thoughtful, are you really trying to learn? Then we're gonna have 10-point assignments that are formative. Those are gonna be more like, okay, I expect at this point you have picked up some skills. Let's practice them. I don't expect you to be perfect. You can get full points without being perfect, but at this point, we should have moved past this is a big mystery and well into, okay, this is an opportunity for me to practice what I've been learning, not this is the first time I've ever been exposed to this. And that's what the lab reports, there are going to be other assignments that fall into that category, but that's how the lab reports will be categorized as well. And so you do not have to get everything right to get full credit on the lab reports. But the idea is, by the end of the lab report, number one, you should have gotten everything done. And number two, you should have mastered the skills that we're working on. And what's going to happen is we'll do a lab report, and then immediately after every lab report is due, we're going to have a quiz. The quiz is going to be a summative 10-point assignment, and that is going to assess the same skills that you worked on during the lab. So it's, I think we'll give you lots of opportunities to practice, ask questions, kind of building the stakes until ideally we get to a place where everybody comes in feeling really good about your ability to demonstrate the skills. Sometimes these quizzes might actually have a hands-on component, but not always. Much of the time, what we're gonna stick to with the quizzes is kind of the intellectual part of it. The rest of those skills, the actual lab skills, I will assess as part of that formative lab report. Yeah?
Did you say that lab quizzes were not the only type of quiz, though?
Yeah, there'll be other quizzes too. Just like there'll be quizzes over solving physics problems. So like when we start doing problems from the book, which we will, not this week, but next week, when we start having like book problems, then I'll have quizzes where I'm like, okay, here's a question like the one from last week's homework. Can you solve this problem? Yeah. All right, any questions about any of that? Okay, so I'm gonna go through the last skill here that we talked about. And this isn't what I wanted. This isn't what I wanted, and this also isn't what I wanted. No, this is what I wanted. So we're gonna go through this last skill that we talked about when it came to interpreting motion graphs. So there were three main things that we looked at starting on Thursday of last week. One was making a velocity versus time graph from a position versus time graph. And then the next thing we looked at was finding displacement from a velocity versus time graph. And today what we're going to look at is an extension of that, using the displacement from a velocity versus time graph to make a position versus time graph. So this is, some of you tackled and succeeded, or at least tackled this yesterday with the activity that we did in class. So if you don't have something to write with and write on, go ahead and grab it. Like no type stuff. This is not something you'll need to turn in. And I'm going to walk you through this, and then you all are going to have a chance to practice it today in class, and then it's also going to show up on the lab and in the lab quiz. So you'll have lots of opportunities to think about it. What it starts with, there's a couple of things that are going to be a little bit tricky. One of which is you'll get it and it'll be pretty quick, but sometimes it's just hard to remember. Mostly, it's just an exercise of taking what we did yesterday with finding displacement and recognizing that if you know how far something moves and in what direction, then all you need to know is where was it in order to figure out where it's going to be after it's moved that distance, right? Like if I tell you I went 10 feet north, then you don't know where I am. But if I say I started at the flagpole out in front of CV, then I went 10 feet north, and then all of a sudden you know exactly where I am. So position is really easy to find from displacement, as long as you have some sort of a starting point. So what we'll start with here is displacement, and so we're going to just use the same technique that we used yesterday, which is to determine the displacement over each time period. So this is doing the shapes thing. And if you look at this graph here, we're going to have some big numbers, because this has velocities of meters per second in 10 and 20 generally, and the times are 10, 20, and 30, 40. So we're going to be moving hundreds of meters. And I'm going to do it pretty quickly because it seemed like you got this yesterday, but stop me if you have questions. So each block here represents 100 meters of displacement. Each triangle, half block, represents 50 meters of displacement. So this one is the only one that we might have to think a little bit extra on. So for this time period, it's going to be 100 meters. For this time period, it's 100 plus another 50, so it's 150 meters. For this time period, it's going to be 200 meters, 10 seconds times 20 meters per second. And this, well, it would be 200, but it's a triangle, so it's going to be half of that. So this is another 100 meters, okay? So that part is pretty quick, okay? And then the next thing that you're going to do is you're going to figure out what the slope of the various sections of your position versus time graph are going to be. Let me show you how that looks, and then we'll see this is where we get our first issue is going to arise here. Okay, so we're going to use the y-axis value, to find the slope of the position versus time graph. That's the opposite of what we did when we made a velocity versus time graph from a position graph. So this value here tells us what the slope on our position versus time graph is going to be. So for this section, our slope is going to be 10. For every 10 units I go up, I'm going to go over 1 unit. Like 1 unit in time will correspond to 10 upward units in my position. Here, I'm going to be looking at a slope of 20. But we have an issue here because the sections of the changing velocity are going to end up with curves. So remember, on a position versus time graph, straight lines represent either no motion if it's a horizontal slope, motion at a constant velocity if it's a straight line that's at a non-zero slope, or changing velocity if it's a curved slope. So we have curves in this section here and in this section here. In this section, we're going to curve from a slope of 10 to a slope of 20. In this section, we're going to slope from 20 down to a slope of 0. So we're going to be starting off moving up 20 for every unit of time we go over. But by the end of this time period, it's going to be a perfectly horizontal line with slope 0, right? And then, so this is going to be generally what we need to graph. We need to put some positions on there. We need to have some slopes. Where does all this stuff go? Well, what we're going to do is we're going to, let's use orange. What we're going to do is we're going to plot some points on our position versus time graph. And we've got to be strategic about that. The first strategic thing that we need to do is we need to think about where are we going to start. Because we don't know. We just know how fast we're going. Now, we'll talk about this more next week, but it turns out that that there is no real position 0. It's arbitrary. So if I say that I don't know where you started, it's valid for all of us to say, well, let's just give it a number. 12, 107, negative 14.2. Any one of those is a perfectly valid number to say, okay, well, this is where you started. But often it's going to make sense to say we started at 0. Sometimes it makes more sense to say something different. But in this case, I'm going to say, let's start at position 0. And the reason for that is because all of our displacements here are positive. So if we start at position 0, then the first point on our graph is going to be time 0, position 0. And every other position is going to be up above that. So we're going to say our initial position was position 0, okay? And then when I make my position versus time graph, just like when you made a velocity graph from a position graph, line them up vertically like this. And I did the best I could. This graph I got from online. This one I just made. But they line up okay. So this is my 10-second mark. This is my 20-second mark. This is my, you can see it's a little bit off, 30-second mark. And this will be my 40-second mark, Okay, so here are my times. And then to plot the points, what we're gonna do is we're gonna add the displacements, all right? So my first location is right here. And then after 10 seconds, I've moved 100 meters. After 20 seconds, I've moved an additional 150, so that's 250 total. After 30 seconds, I've moved an additional 200, that's 450. And then after 40 seconds, I've moved another 100, so that's 550. Did I mess up the math? I think that's right. Okay. So that means that I need to have room to get all the way up to like close to 600. So let's figure out what our interval could be here. If this is like 100, 200, 300, 400, 500, 600, that would work, right? So if I say this is 600 meters right here, and then this is 100, 200, 300, 400, 500, we've got room to fit all these displacements on the graph, okay? And if we had some negative displacement, then we're going to be going up and down. We really only need our y-axis scale to have room for the biggest maximum positive and the biggest maximum negative displacement for any time period. In this case, though, we have room to get up to 550 here, so let's roll with this. So after 10 seconds, I've moved 100 meters, so I'm going to be at position 100, so I'm going to plot a point there. And after 20 seconds, I've moved an additional 150 meters. So I'm going to move 10 seconds to the right on my x-axis, and then up 150 meters on the x-axis. Come on, you can do this. I want to draw dots here. There we go. Excellent, excellent. And then after 30 seconds, I've moved another 200 meters. That's going to take me to 550. So that's up here. There's my 550. No, that's not right. Sorry. My bad. 450. Okay, that's going to bring us to 450. And then after 40 seconds, I've moved an additional 100 meters, so that takes me all the way to 550. Does that look right so far? Got all my points plotted correctly? Okay. And then we know we have a constant velocity for the first 10 seconds. So that's going to be a straight line. So that's easy to draw. We just make a straight line. And we have a constant velocity for the time period between 20 and 30 seconds. So that's going to be a straight line. Okay. And then we have curves for the other two. So this section is going to curve from a slope of 10 to a slope of 20. That's pretty easy. I can just kind of like draw this as a curved line connecting these. And I'm having my calibration is just a little bit off, so things aren't quite matching up, but I'll draw an overall sketch of this when I'm done so you can see what it would look like if I was using pencil and paper. This one's a little bit different, because how do I do this? Do I go like this? Do I go like this? Like, what do I do? And the answer is, it's gotta finish up with a horizontal slope of 0. So when I'm done, my hand is gonna be moving straight to the right. I have to start here with a slope of 20, so that means this last bit is gonna look like that. Okay. So if I were, again, if I could draw this all in one fell swoop, it would look like this. Straight line, curving, straight line, curving. So we have a straight line here, a slight upward curve here, straight line here, a downward curve to horizontal here. This is the hardest technique because you have to do so much, and drawing the curves can be kind of tricky. But with a little bit of practice, you'll get it. And we'll have some practice today. I have 3 practice sets that we'll do over the course of the next 7 days. So you'll have lots of time to practice, and there's an opportunity to do this on the lab as well. Okay, so at this point, there's one last trick that I'm going to show you in class on Thursday, which is how to find instantaneous velocities, which is, we haven't talked about it yet, but talk about it and I'll tell you about it on Thursday. Other than that, at this point, you've learned most of what you need to learn for interpreting position and velocity versus time graphs. There's one more graph that we'll be looking at, which is acceleration versus time. We haven't talked about that yet. And there's all sorts of little tricks, and certainly the more you practice, the better you get. But it actually, like, the idea, like, I'll be honest, when I look at these two graphs, if you showed me this graph right here, sight unseen, if I walked in the room and you said, here's a velocity versus time graph, what does the position versus time graph look like? I would not be able to envision it instantly. I wouldn't. I would look at this and I would probably even say it wrong. Like, if you put me on the spot and said, you have 10 seconds to explain what this motion looks like, I guarantee you I would screw something up. Because when I look at this, I want so badly for this to be something not moving, and then moving one way, and then not moving, and then moving the other way. I want this to be a position versus time graph, but it's not. So part of the exercise of what we're doing is recognizing that it's so tempting to misinterpret these graphs that you need to just force yourself to kind of go about it methodically. This is a velocity versus time graph. This is constant velocity. I'm moving at a constant speed here. Here, I'm speeding up, moving in the same direction, faster and faster and faster. Now I'm moving at that faster speed for at a constant rate for a certain period of time. And here, I'm not moving backwards, I'm slowing down. I'm still moving in the same direction, but I'm going slower and slower and slower and slower until here I stop. And you can see that what that leads to is an object that is constantly moving in the same direction. Slowly at first, then faster, maintaining that speed, and then slowing down and eventually coming to a stop. Yeah?
Does it only come to the stop if it has more, like if we could see more of the graph?
Not necessarily. So if we were to see what happened next, we might not visually perceive it as stopping. But technically, it had a velocity of 0. So yeah, it stopped, but it might have only stopped instantaneously. Okay, so the next thing that I'm going to ask you to do, so actually before I do that, does anybody have any questions? Okay, and then the next thing I'm going to ask you to do is something that is on Canvas, and I printed this out, but I forgot to get it off the printer, so I have to go grab it real quick. I'll show it to you on the computer so that you can see what it looks like. It's just a exercise, and this exercise involves sketching a velocity versus time graph, given a bunch of information, and then using that velocity versus time graph to sketch a position versus time graph for the same object. There's a bunch of stuff here that's not it's not tricky. There's nothing new, but there's some limitations. So for example, we're looking not for the entire position versus time graph, but just for the position versus time graph starting at time 2 seconds until time 5 seconds. So how do you deal with that? It's something that you haven't done, but it's not really new either. It's just something that you have to think about. What I want you to do is, and so I'll go get this in just a second, what I want you to do is you can approach this in one of 2 ways. The first way is you feel like you have got this nailed. Then I want you to quietly take the paper when I give it to you. You can grab, if you want a ruler, you can get a ruler. I want you to go find a spot where you can work entirely individually and see if you can get it 100% on your own with no help from anyone. And that's just a challenge. You don't have to do that. If you would prefer to work in groups, go ahead and do that. If you want to challenge yourself, though, what I would say is don't start it and then be like, oh, I need help. Like, just go from start to finish, see what you can do, because then that'll give you a really good idea of what it would feel like. For example, if I were to give you something like this as a quiz, which I will. So eventually you're going to need to be able to do this on your own, completely help-free. Okay, any questions about that? This is posted to Canvas, so if you want to take a look at it while I go get the paper, you're welcome to do that. Otherwise, I'll be right back.